What we're going to do here today is not the how to use it, it's the what is it. It's the recovery ropes and gear strap, so that when you go out and you shop, obviously we'd love to get you some gear here, but wherever you buy gear, we want you to have the right tools and the right knowledge so that you get the right gear so that no one goes out there and gets hurt. This year in Flagstaff at Overland Expo West, we held 2 recovery gear clinics in the Step 22 gear booth. What follows in this video are 22 sound bites from some of the topics we covered in those clinics. For the rest of this year, we will continue to hold recovery gear clinics at most of the events we attend. We hope to see you in person at an event soon. Pretty much everything that we go over today is largely going to come back to ratings and raw materials. And one of the most important parts of recovery gear, both what you have in your kit now and what you're going to be hopefully go back to review, is labeling. And what we've done is put together a program that gives you all that you need to know as far as raw materials, ratings, length, width, and everything, and the terms for what that product is meant to be used for. Something to keep in mind is all the ratings that we give you, or wherever you buy your gear, those ratings are for brand new and non-used products. Okay, as soon as you get these out, start working them, yanking on them, washing them, dirt, sun, UV, and all that stuff, those ratings are going to drop down.
The materials in which we use to make these straps, make these ropes, they all start with a building block. You can buy this building block from many different web suppliers, many different rope suppliers. Knowing the building block in which you're purchasing is where it all starts, right? That minimum, what we'll call unsewn tensile strength for webbing, or minimum tensile strength for rope. So that building block, what we take, then we produce the toe straps, kinetic energy straps, you name it. So these products all start with a building block. For instance, in a single ply configuration, this piece of webbing is 9,800 pounds unsewn tensile strength per inch of width. Say that 10 times quick, right? So let's just round it up to 10,000 because I'm bad at math. 10,000, 1, 2, 3, 30,000 pounds is my building block. Now I start to sew a splice into it. Putting a needle through anything is destructive, right? So there's what's called a manufacturing loss of efficiency, or a manufacturing efficiency. So I started with a 30,000 pound building block. I've stitched into it. I'm not going to ever see 30,000 pounds. That's one of the biggest misnomers in any piece of rigging, is manufacturers don't. They take the breaking strength of the product and divide by 5 or divide by 4 or divide by 3 and give you that working load limit. They haven't taken their configuration zone and break tested it, right? So it's very, very important when we're taking a building block to put it into the configuration in which we're building, and then break it and divide by 5 or 4 or 3. So now let's talk about, so we're talking about maximum or breaking strength. Now let's talk about working load limit. So working load limit is a term defined as not to exceed. So working load limit, don't ever exceed the rating on the tag, right? You start exceeding those ratings, and this goes back to what Adam said initially, using like rated equipment for the equipment in which you're recovering. If you use straps that are not strong enough for the equipment in which you're trying to recover, bad things happen to good people, okay? So ratings are very, very important. Also, as Adam mentioned, those ratings, that's new and unused. So it's UV starts to beat up on it. Nylon loses 15% of its strength when wet, damp, or moist, as reported by DuPont in 1984. So at the end of the day, everything diminishes, right? So break strength, working load limit. Working load limit in many categories is 5 to 1. So taking that sewn, we bought that building block, we've sewed into it, we've lost 15 to 20%, we've done our break testing, we then divide by 5. So in this scenario, 4,800 pounds, we started with 30,000 and we're down to 4,800 pounds in a 5 to 1 sewn configuration. So that's the story of breaking strength and working load limit. Now, if you're buying your equipment and all it says is breaking strength, you as the user you should not have to determine that adequacy. You should not have to be dividing because it's an unsafe practice. That should be done for you by the manufacturer. So breaking strength and working load limits, if you don't see those on products, I always jokingly run far and fast, right? Because we're not telling you the limitations, and that's just not a safe practice. But that's a little bit about breaking strength and working load limit. So breaking strength is important, yes, but working load limit as defined is also very important. And then seeing those two numbers, you can really start to make sense of things. One manufacturer might say working load limit on this strap might be 20,000. He's only using a 3-to-1 design factor. Take that same 60,000, divide it by 5, and now that strap is good for 8,860 pounds. So you see where that can really make a difference in, and you're looking at it going, but it's the same. There's no magic fiber out there. There's no magic web. It's just difference in design factor.
Big problem right now is a lot of the marketing out there is going to give you terms and stretch that are way beyond stretch that is designed to be at workload limit. So these products that we're going to talk about are designed to have about a 10 to 12% stretch at the workload limit, but there are some marketing programs out there that are going to give you a much higher stretch. Like Mike said, the raw material we all get from mostly 1 or 2 places, right? So it's the same stuff. And you'll come here and say, well, you only stretch 10 or 12%. Down the road, they'll stretch 4 times that because they're giving you stretch at break strength. For me, that promotes using that product up into a break strength, which we never want to do. So just be aware. Hopefully you guys leave here today and you know a bit more about the terms so that when you go buy gear, you can weed through those programs for marketing and actually know what you're looking for: break strength, workload limit, and know what those actually are.
So the marketing terms of, oh, we're 25% elongation, well, that's at breaking strength. Nylon and polyester is made by many large conglomerate sources, right? There's no magic polyester, there's no magic nylon. It's all the same building block. So at the end of the day, the ratings and the stretch factors, they're all within a few percent of each of the large petrochemical companies that are producing this raw fiber. I always recommend like-sized ratings. If your gross vehicle weight is 6,000, get a 6,000 pound strap. If your vehicle is 12,000, get a 12,000 pound rated strap. At the end of the day, when you match your gross vehicle weight with your weight ratings on your straps, you're going to get that elasticity that we like to see, that kinetic energy to help the recovery effort. If you use too large of a strap, so you pick a 12,000 pound strap and you're pulling out a 6,000 pound truck, you're not going to exercise that strap enough to see the kinetic energy. It's going to hit pretty hard. Why? Because the tensile is way up here. So again, that like-sized equipment is going to be optimal. So your gross vehicle weight matching the working load limit of your equipment.
It's important for you guys to know your trail weight of your rigs. You've got your rig weight that it was off the lot. So when you go to get equipment, when you're looking at your trucks, you know, when it was fresh, but now you put on steel bumpers, then you put on your rooftop tent, you got your water and all the stuff that you carry, when possible, when you're loaded down for how you load your rig for when you're out on the trail, try to get it weighed, because you might be a bit off on what that weight is. So we call that trail weight. So that's what your rig is actually going to weigh when you're out there on the trail.
Don't overload your rigging. Stay within the confines of the working load limit. Inspect your gear. Don't use damage rigging, and pretty good chance you're going to go home at night.
We talk about raw materials and ratings and everything. As you guys can see on down toward page 1 here on materials, nylon, polyester, HMPE, UHMPE. These are materials. These are the raw materials that the products are built on. The next line where we talk about Dyneema, Spectre, Plasma, all these different names. These are names that companies have taken a raw material, nylon, polyester, whatever, done what they're going to do to it, and given it a kind of a trade name, right? So you need to be able to work through materials, nylon, polyester, UHMPE. It's important to know, this also comes back to tagging, is what materials you're working with. So what you see here is polyester, and polyester is going to be what we say no stretch, minimal stretch, right, for winching. So when you're out there all alone, you've got your winch and you get stuck, you're going to be working with possibly plasma or your steel cable that's on your winch, your tree strap that can wrap around a tree or a rock or whatever that is going to be polyester. So this is slow, controlled recovery. You're winching in nice and slow. You don't want any stretch in that line because you're going to store energy. And if something's, the point on your rig breaks or your strap wasn't inspected and it breaks, you've got a bunch of stored energy. YouTube, right? When you go on there now, it's when you see crazy stuff happening.
So winching, that's what we call controlled recovery. It's a very controlled environment versus you're stuck 2 feet in the sand. You need some energy to get that truck and trailer out of that sand pit. So there's different types of recovery. One would be controlled, and one is kind of the jerk or the yank scenario.
Then we get into nylon. So we've got nylon straps and then nylon rope here, right? So both stretch. So again, something you're not going to want to use while you're winching, but this is, your stuck rig and then you got a nice truck to come by and pull you out. Kinetic energy, right? So you're going to get a little stretch out of these, we don't want you to gun it. There's some that will tell you, get a bunch of slack in the line, literally will tell you, rev your engine as loud as you can and punch it, right? It's a bad day. You only go as quick as you have to, as slow as you can to get that pulled out. There are times when you're in, deep stuff and you're gonna need to get more on it, but the nylon's gonna give you that stretch. Last year I had a team that actually did a race and came to me and said the bumper flew off. They were using a polyester strap to do a kinetic recovery. So they put a bunch of slack in the line, had heard of that, put some slack in the line and gunned it. Polyester, right, little to no stretch. Bam, they shock loaded it and the bumper literally flew off. Okay, it wasn't labeled. They had no idea what they had and they were in big trouble. So that also comes back to labeling. What's the material, and then knowing what that is.
Good way, just to let you know, all of the polyester web that we purchase from the mills, we require this blue center line. That's what we call a surface tracer mark. That surface marker indicates polyester. You look at nylon, it's not there. The other thing we did was our thread. We actually twisted a blue strand in the thread because on a Monday morning after Willie Nelson concert, do I have the right white polyester, white nylon? I don't know. So about 20 years ago, my father had the brilliant idea. He goes, Junior, let's put a blue tracer. And I go, Pops, that's a damn good idea. So when you look at that, now that doesn't mean that every polyester product you buy is going to have a blue tracer yarn, but at the end of the day, it should have that center tracer. There's 3 major webbing mills: Opperman, Southern Weaving, and Murdoch Webbing. All 3 of them, industrial lifting and pulling web, all use that blue surface tracer. It's a requirement by Web Sling and Tie Down Association. So in the States, that's standard. Blue line polyester, low stretch. No blue line, nylon, double the stretch. Again, that kinetic recovery. So. Okay, so real quick, and I'll do this from I'm a visual person. So nylon, the highest elongation out of any product, 8 to 10% depending on which mill you buy it from, okay? Elongation can be referred to as elasticity. How much does it stretch? 8 to 10%, right? Polyester is next in line. Polyester is 3 to 4% depending on who you're buying it from. HMPE, high molecular polyethylene, is less than 1% at rated load. So you're going from 10% to 4% to less than 1%. This is why knowing the materials and what they're for is very, very important. a product with less elongation in a dynamic pulling situation is going to more greatly shock load those connection points. So if you had a choice and you had these tools in your toolbox, this is the best choice to use in a dynamically loaded situation. In a static towing situation or a winching application, the low stretch is better way to go because you're using less drum from your winching material, whether it be wire or HMPE.
You need to pay attention to what is the actual material, not as the name that they gave it. Next in line for terminology is kind of the product. Is it an anchor strap? Is it a tree strap? Is it a tow strap? Is it a recovery strap? Okay, there are no standards. No one's telling us this is what you need to put on this product if it's made from nylon or from polyester. So you got to kind of take a look at all of these terms, the names that have been handed down to the raw material. What is the raw material? What is the end use? This is an anchor strap. That's how we label it, right? We say anchor strap. A lot of times you'll see this as a tree strap. For winching, you're going to wrap it around a tree, right? It's an anchor strap. It can be wrapped around a rock or a pole or whatever else you've got out there. So sometimes it's a tree strap. You can go find the same exact product labeled as an anchor strap or tree straps.
In a kinetic energy recovery situation, or I should say a dynamic recovery situation, nylon is always the best choice. Why? Remember, it stretches. We get that elongation, that elasticity to not as greatly shock load those connections. So nylon products, there's several different ways it can be built. So this is what we call a 12 strand or a single braid construction. 12 strand is 12 individual pieces of rope that comprise that total capacity. Those ropes are all built, coated. There's different processes in which you can look at some of the different products, and some might use multi-groups and coat them, then build one strand, then build a 12 strand. That big purple rope there, that's a patented rope called a 12 by 12 construction. So they're taking 12 ropes, making one strand, then making another 12 strand, 12 by 12. So a lot of different stuff out there. Let's lower it down to the lowest common denominator. Nylon, a dynamic recovery rope, 12 strand single braid. Inspectability, you can open it, you can inspect the inner structure, very easy to splice. I literally take the bitter end of the rope, I open the core, and I put it right back inside of itself for a certain amount of what we call fids. A fid is defined as 21 times rope diameter. This rope calls for 2 fid tuck. 1 inch rope, we'll keep math simple. 1 inch rope, 21 inches, right? 21 inches, 1 fid, 2 fid tuck, 42 inches. I've got to have a 1 inch rope spliced to obtain the tensile of that rope. Dyneema on the other hand, or plasma, 3.5 fid tuck. So see, the stronger ropes, you have to splice it a greater length to comprise that total tensile of the rope. So nylon 12 strand, easy to splice, easy to inspect. Now, because it's easy to open, to look at, to inspect, what also can happen? What's the susceptibility there? Sun, dirt, rocks, contaminants, all those things that can greatly affect that overall strength, that bring you from that minimum breaking strength and start lowering that design factor, right? Everything diminishes over time. Our favorite pair of Levi's, our favorite pair of shoes, everything wears out, including your recovery equipment. So now, 12 strand single braid, easy to splice, easy to inspect, susceptible to dirt, rocks, grime, UV. Now we're going to talk double braid. Double braid is a term in which you have a core and an outer sheath. That outer sheath protects the inner core. So you can, easy to see here, but at the end of the day, you can also pop it open, and that's how we splice it. We open that outer sheath, we pull the core out of the rope, we splice the core, we feed it back into itself and pull the cover back around the eye. So this is what's referred to as a double braid. You'll hear it a lot in the marine industry referred to as yacht braid. So running in those pulleys and shivs on sailing ships and things like that, sailing boats, it had that outer sheath greatly protects the core from UV degradation, that UVA, UVB damaging ray. It also protects the core from abrasion. So now that core is taking the cover is taking the abuse, not the core. So much greater durability, much greater longevity, but at the end of the day, two technologies, right? Core strength, cover strength, you're gonna pay more for it. You're gonna get a lot longer life out of it as well. So you get what you pay for with rope. Most important critical thing to remember is just like a pair of jeans, your favorite pair of socks, everything wears out, including your recovery gear. So what you start out with on day one is not what you end up with on year 5 or year 10. Everything breaks down from ozone, UVA, UVB exposure, abrasion, dirt, grit, grime. All those factors contribute to a premature failure. Now, each of these products all have their own susceptibilities, weaknesses, and strengths, right? So nylon, very susceptible to UVA, UVB. Total degradation in 5 years of exposure, okay? Polyester, after 2 years, plateaus, 30% loss. HMPE, extremely UV stable, so up to 5 years we're losing less than 5%. So just from UV perspective, let's go back to nylon and polyester. Nylon and polyester, this is I think it was either a 5 or a 10-year report done by the Web Sling and Tighten Association. Both after 2 years lost 30%, nylon and polyester. Nylon, total degradation, polyester plateaus. So if it's just a UV situation, polyester is the choice every day and twice on Sunday. The chemist said that polyester on a microscopic level creates a scab around itself, and that's why it stops degrading and nylon goes to total degradation. So very interesting. And back to HMPE. HMPE stands for high molecular polyethylene or high modulus polyethylene, depending on which chemical company. Then there's UHMPE, ultra high molecular polyethylene, where they're taking and performing additional processes to create higher strength. So ultra high, high molecular polyethylene. Polyethylene is a few molecules away from being plastic. Again, knowing susceptibilities. Because it's plastic, it has a very low melt point. 140 degrees Fahrenheit is the maximum this product can be used at sustained temperature. Polyester and nylon, 194 F. So here again, knowing your equipment, knowing what it's for, and those those material types help you to realize what you're working with.
Brand new gear, you're still going to inspect it. If you buy it online or you went to a store, whatever, maybe you thought you bought nylon, it shows up and says polyester. You know, you're going to unwind it, you're going to take a look at it, inspect it, even though it's brand new. Before you go out on your trip, you're probably loading up your rig. If you keep your recovery gear in your rig, still pull it out, have a look at it, make sure you think what's there is what's there and everything still looks good. While you're on the trip, something goes wrong and you pull it out, look at it right then and there. When you're done, right, you don't realize you got a tear, you pulled it over rock, you didn't see it, don't just throw it back in there. That way you know when you get back you need to replace that. And then what I like to say is, you know, you're out there, expect your strap all the time, you think you know what you're looking for, hand it off. Hey, can you have a look at this? And you go, hey, this is a bad deal, right? So just don't always trust your own gut. Make sure you get some help with that too. And as you guys see on here, I say treat your recovery gear like you do your tires, right? You don't wait for your tire to blow before you replace it. You look at, hopefully, you look at your tires, you got a couple years on them, there's a bunch of UV, they're starting to crack, the tread's getting low, it's raining, you're kind of slipping around. You're gonna go get new tires. We get people a lot of times, you know, oh, my strap, you know, is perfect, you know, how it's 9 years old and all this stuff, but it didn't break yet. Recovery gear is not the type of tool that you use until it breaks, right? You're going to want to replace it long before it breaks. So you're not that guy on YouTube with that flying through, right?
We all have freaking computers in our pockets. Use those. Go back to your manufacturer, snap a shot, hit it to the info at, you know, whatever, Bubba Ropes, Voodoo, Checkered Flag. Hey, what is this? Make them, as the rope experts and the manufacturers, define that criteria. It's simple. It's removal from service criteria. It's snags, cuts, punctures, melting, charring, chemical. It's a clear and defined list. So rely on the manufacturer to help you inspect your gear and to understand when it's good and when it's bad. When you're purchasing your recovery equipment, don't be afraid to ask people, what's your design factor? And if they look at you and they kind of go cross-eyed, hey, do you have any removal from service criteria? These are all important things that are going to keep you safe. You're going to flip to some inspection criteria. If a manufacturer can't tell you when it's bad, when you should remove it from service, and what the design factor is, I say run far and fast, right? Because this is all stuff that's going to keep you safe in the field. I like to boil things down to the lowest common denominator. Cool, dry, dark, and free of environmental damage. And free of environmental damage is away from gas vapors, fumes. If you're going to store it outside of your Jeep, don't put it by the grinding station. Don't keep it by the paint booth. That's what I consider environmental, free of environmental damage. Okay. Away from heat sources. Heat will degrade fibers. So around those heat sources, those fibers start to break down. So free of environmental damage. So let's go back to cool, dry, dark. Cool, obviously we want to keep it below the nylon and polyester in the industry, the rigging industry, crane world, we tell you 194 degrees Fahrenheit. Pretty darn high, but at the end of the day, you don't want to sit there and have that strap there for a year. Trust me, it will. But at the end of the day, we allow it to be used on hot boils, the boil makers, the tubes when they're tearing down power plants. 194F. Where was I going with that? We were talking cool, dry, dark. So cool. 194F, always your maximum. Keep it away from hot exhausts. Exhausts are killers. You know, getting around, wrapping around where you may only have, keep it away from hot exhaust. Exhaust usually runs in the 250 to 400 degree range. It'll melt your strap, any strap. Dry. You don't want to grow bacteria and molds, okay? It will happen. A lot of folks ask about, can we wash the mud out of our straps? Can we wash it off our ropes? Absolutely. Warm water, non-bleaching agent. Bleach kills nylons and polyesters and UHMPEs. The safest thing, simple green. Nothing citrus-based. Citrus-based usually kills your nylons, polyesters, and UHMPE fibers. Simple green's the safest. It's at every Home Depot and Ace Hardware. Warm water solution, simple green. You know, take your products, soak it in, work them around to get all that mud loose, and definitely going to extend the life of your products. Most important factor, store it in a manner in which it can dry completely, or before you store it, excuse me. So hang it out, dry it, don't leave it out in the sun for more than a day or two, absolute maximum. Bring it back in, roll it up. Now it's ready to be stored. So cool, dry, dark.
No pressure washing, because you're going to end up shooting that dirt and all that grime deeper in, and then you use it and it grinds away internally and you just break it down even more.
And I can tell you, Arizona desert, granite base rock inside your ropes, forget about it. It's going, the more crap that's in there, it's going to tear up your ropes. It's a granite based.
What is shock load? Shock load would be getting a lot of slack in the rope, and you know, the pull rig, the tow rig, and there are some instructions out there that are telling you get a bunch of slack in the rope and floor it, hear the motor roar, gun it, you want to yank that thing out, right? Go as slow as you can, as quick as you have to. So we say you don't want to shock load. A lot of times the recovery points that you have on your rigs, you should know your recovery points on your rigs are properly rated. You're not grabbing whatever I can wrap this around, that'll be good to go, and you shock load. That's when it's a bad day. That's when this stuff starts flying through the air and you end up on YouTube. So ignore the instructions that tell you to shock load stuff. We want to avoid shock loading whenever possible. Talking about steel shackles versus soft shackles, which are all the rage right now. Steel's not dead. Mike's going to talk a little bit about Van Beest.
Look at these two shackles, and I'll pass them around. See these forge or flashing marks on the inside? Look at those forge and flashing marks. There's two processes in making a shackle. One is called a drop forge. Drop forge is a multi-hundred tons of pressure that hammers that out. There's a top and a bottom mold. They put the material in and hammer, 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 boom, shackle's born. Upset forging, used by Van Beest in the Netherlands, they take a perfect round bar, they bend it in a jig, and then they form on the ears of the shackle in which the pin integrate to. So because they start with that perfect round bar in the upset forging process and just forge the ears on, it's a much it's a more controlled process. It's a better process that doesn't hammer that steel, so it's actually a stronger product. So the main difference, though, that's a clean drop forge. Some of the domestic shackles that you're paying 2 and 3 times more for, i.e. Crosby, Columbus McKinnon, Cooper Campbell, their dies are old and the flashing marks are huge. You look on the inside radii of the shackle and you're seeing sometimes a 3/16 or an 1/8 inch edge hanging out, right? Edges will damage your products. Any enough tension and compression on any edge is going to cut a synthetic. So when you look at a shackle, round bar, perfect. We call these synthetic friendly. So drop forge versus upset forge. Okay. One of the other major benefits of green pin Van Beest is they recess their lettering versus upset. So when you look at the lettering here, you've got it all standing off. One of the highest end Crosby McKissick Crosby shackles, they put their name and their working load right at the crown, right at the working area of the shackle, can cut synthetics. So when you look at the recess here, that's showing green pin, that's the name or trademark, that's the grade of the shackle, and then that's the working load limit, 3.25 metric ton. So little difference in how the shackles are made, upset forged versus drop forged, raised lettering versus recessed lettering.
A lot of guys we see are coming back in and these are getting tore up because I didn't want to use my steel shackle, I got the soft shackle. There's still good use for these. Even a minor sharp edge, once you get some force on it, we'll shred these up. So
tension and compression, enough tension, enough compression will part anything. Wire, chain, web, HMPE.